selamat malam semua. Apa kabar? Selamat datang ya guys di webinar keempat kita. Di sini kita akan discuss tentang Telecom Customer Churn Prediction using Machine Learning and Python. Nah, di sini Mr. Ansu Pandey nanti akan jadi speaker kita dan jelasin bagaimana sih implementasi machine learning dan Python di Telecom industry. Nah, please stay tuned until the end karena nanti kalian akan dapat sertifikat otomatis dari sistem kita. Oke? Mr. Anshu, please.
Yo, thank you, Andev. Thank you for the introduction.
Sure, thank you, Mr. Anshu. Please.
All right, everyone. So we're good evening and welcome you all to this webinar. In this webinar, we're going to be talking about the introduction to artificial intelligence, machine learning, and mainly we'll be looking into the demo, telecom churn prediction using machine learning and Python. So let's get started. At any point you have any question, any doubt, you can drop that up in the chat box over here, or else you can put that up at the end of the webinar as well. So let's get started. All right, so we're going to first talking about the sort of idea of what exactly AI machine learning is. Then we're going to see some of the case study that of some companies which are operational into Indonesia and are working in the domain of artificial intelligence. And then we'll see the project demo. The first thing, what exactly AI is? Well, so the idea of artificial intelligence is about making computers or software machines act intelligently as good as humans. So for example, let's say we humans do remember patterns. We remember our friends and family members. How do they look like? We remember their voice. We know how to ride a bike. For all these applications or for all these operations, we do not follow if-else rule. Nobody says us that if the nose is pretty big, it's my sister or that's my brother. We don't follow those rules. We remember patterns. So AI is all about providing these kind of intelligence to machines. This is logical definition of AI. Technically, it is about making computers, software, machines act intelligently by making use of number of algorithms. So the research in AI begins since late 1950s, and in early 1950s, the optimism and the talk about AI began, where people started about it and then started talking about it and then started doing research. So far in the last number of decades, there have been a lot of researchers from professors, researchers, inventors, research organizations across the world in developing simple AI applications using mathematical algorithms. Today, AI is a collection of those algorithms. When we implement AI in business industry, we don't invent anything new. We make use of the existing algorithm and we perform in creativity on the application part. So technically, artificial intelligence is a collection of mathematical algorithms which can be used to develop the intelligent capability. Then there's a term machine learning, very much frequently taken along with that. The idea of machine learning is that out of AI, some of the algorithms consume data to build intelligence, and all those algorithms which use data to build intelligent capability fall under machine learning. So that's the difference between AI and machine learning technique and AI non-machine learning techniques. The use of data is the main difference. So you can say ML is collection of those all algorithms which make use of data to build the intelligent capability. Then there's a term called deep learning, another subset of machine learning. And mostly it's like these are even advanced, or you can say effective set of algorithms under machine learning. A subset of machine learning wherein these algorithms do not require manual feature extraction. which is what needed in machine learning algorithms. So these days, the kind of advancement and advanced applications that we get to see, like self-driving cars, right, and the effective chatbots, the banks detecting counterfeit notes, many of them are backed by deep learning. So machine learning and deep learning is all about using data to build intelligent capability. When it comes to using data, we don't start with just feeding data to the model. We perform a lot of engineering on data, statistical analysis on data. The field wherein we talk about performing statistical and probabilistic analysis, we call that as data analysis. What we do here is we perform probabilistic and statistical analysis on data to interpret some patterns out of it. And you combine this with this so far, machine learning, deep learning, this is what the field is usually popularly called as data scientists, data science, or these days, even the broader picture of data analysis. Again, when you work with data in the form of images, which we get from video frames, or we get from, let's say, cameras, we get from scanned devices, we perform image processing on that. And when you combine image processing with machine learning, we call that combined field as computer vision. In a similar manner, when we work with text or speech processing manually, and when we combine this with machine learning and AI, we call this combined field as NLP, natural language processing. So these are all multiple fields, whether you talk about computer vision, whether you talk about data analysis and natural language processing, all make use of machine learning and deep learning capabilities. In computer vision, machine learning is used for face recognition, self-driving cars, signature authentication, bank detecting counterfeit notes. NLP, the applications like chatbots, the algorithms making machine translation, sentiment analysis on text data, text classification, email classification on Gmail. These all applications of NLP are backed by machine learning algorithms. Similarly, in data analytics domain, the applications like churn prediction, which is what we're going to talk about today, and let's say stock value prediction in stock market, or you talk about the risk prediction in banking, finance, a number of financial predictions, forecasting in sales, weather forecasting, the demand forecasting, upsell, cross-sell analysis, recommendation engine on Amazon or Netflix. Many of these applications are backed by machine learning and deep learning. So that's the sort of connection between AI, ML, and deep learning. Let's go further and talk slightly more about it. So what exactly is AI then? Well, as we have discussed, it's the way of making computers act intelligently, right? So the science and engineering of making machines imitate the human intelligence is what we call as AI, right? For example, the way humans can drive their car effectively, making a self-driving car solution is an AI solution. The way we humans can recognize faces of our friends and family members, making a software recognize faces, it's what we call as AI. What is machine learning? A subset of AI where the algorithms develop intelligent using data. We also call it, it's a field of computer science where we make the algorithm learn from data without explicit programming. Explicit programming is like without using if-else rules. Right. So what do you do in machine learning actually? Well, so we bring data from the business, right? We bring data from the business, feed the data to a machine learning algorithm, and train the algorithm. We get a trained model here. And we feed this trained model is now we can use it for doing real-time prediction. So if you feed only input data, the model can give us prediction. We can check whether it is good If it is good, we'll take it to production. If not, we'll retrain that. So this is how machine learning actually works out, right? This is much more like the usual human learning. If I have to learn to ride a bike, what I'll do is I'll go to street, try to ride a bike. If I'm doing that effectively, I'll keep on doing that. If I make mistakes, I'll evaluate myself and try to use a better way of riding bike. The same way, in the algorithm, we feed data, make the algorithm learn from data. We do prediction. If prediction is right, we take that model to the production environment and deploy it. If the prediction is not right, we retrain the model and then again evaluate. Right. So machine learning models are, there's a question, what exactly are machine learning models and how do you evaluate it? Well, machine learning models are trained algorithms, right? So here we have algorithm, and to this algorithm we train using data. So a trained model is, you can say, is what we call as machine learning model. So over a period of time, there have been a number of mathematical algorithms which have been developed, which can be used, which can be made to learn from data. For example, let's say, if you talk about Facebook, right? Facebook, we have been uploading our pictures, friends' pictures. 4-5 years back, when we used to upload pictures on Facebook, it used to ask like, would you like to tag your friends? We used to say, okay, sounds good, let's do that. So we used to tag our friends and family members. Over a period of time, it started recognizing a face. This is a face. Who is that? Would you like to tag him or her? We used to say, okay, sounds good, let's do that. Now when we upload our pictures on Facebook, it recognizes that this is Mr. X and this is Mr. Y. Would you like to tag them? So there is a machine learning model which has learned from our data which we have been uploading on Facebook, and after training, it is able to recognize the faces from the pictures that we upload. So how that model has learned actually? So there is a mathematical algorithms in backend. There is a mathematical algorithm which can learn continuously from data or can be trained using past data. The trained algorithm is what we call machine learning model. So there have been number of developments in machine learning and in field of AI. So machine learning model is such an algorithm which can learn from data. There are multiple similar algorithms. All of them have different capability. So that's the idea of machine learning model, an algorithm which has learned from data. How to evaluate it? Well, to evaluate it, we collect some test cases. Let's say my name is Anshu. I can check my face, train an algorithm, and then I can show it my face. If it is doing right prediction, I can check it. Okay, it is doing right prediction. So we can validate it that, okay, this model, I have tested it on 100 observations and it is doing right prediction. If it is doing right predictions on all 100, we can validate it and deploy it to production. So to evaluate it, we make use of some test data. Label data, that means some data for which we have questions and answers both. So questions we can feed to the model, get the prediction, compare the prediction with answers, right? So you have questions and answers. What you do that is we feed questions to the model, get the prediction, then compare prediction and the answer, the right answer which we know from here. That's how we evaluate it. I hope this answers the question. All right, so that's the idea how machine learning works out. So as a, in order to become an AI expert, this is what one needs to have idea of that, well, what are those algorithms and how do they work out? And what kind of algorithm should I use? This is what you see, like there's a need of such people who know those algorithms, who can understand those algorithms, who can implement such solutions. That's what one needs to learn to become a machine learning expert or a data scientist or an AI expert. Well, so on that, I hope this answers your question. Okay, so we'll go ahead further. And now we'll talk about applications, where it is used. Well, so these are some of the typical applications. Optical character recognition, an algorithm which can recognize handwriting or handwritten text by humans. That's what we call as an application of optical character recognition, which is backed by machine learning. So we train machine learning algorithms with some data of handwritten text to be able to recognize the handwriting. Similarly, the political campaigns to find out that what is the mood of public and how the citizens are positive or they are negative about something. Policy prediction, surveillance systems in cities from cameras recognizing crimes and criminals, identifying them from the CCTV security networks. Facial recognition, right? And similarly, the self-driving cars. The advertisements on Google, if you buy a product, if you search something on Google, let's say I search for shoes, after that, for a couple of days, every website I visit, I keep on getting advertisement of different shoes I might want to buy. The business intelligence in advertisement, that's where also machine learning lies into. Personal assistants like Siri, Cortana, or Google Assistant are also backed by machine learning and deep learning. The news feeds on Facebook or the recommended questions in Quora, right? Recommendation engines on Netflix, like the movie recommendation, YouTube video recommendation, Facebook friend recommendation, Amazon product recommendation, are all backed by machine learning. So this is the sort of idea of the applications of ML. All right. See, similarly, you can also try out this particular Android app. This is Google Translate. You can try out this app to read one language in another language. If you don't know language, let's say that I don't know Mandarin language, so I can use this app which can translate that in real time in English. This helps a lot when you travel to different countries. This is something, an app you can try out. This app does real-time optical character recognition plus machine translation. That means it recognizes characters from the images and also translates that into another language of your choice. This is also one of the examples you can try out, which is backed by machine learning and deep learning. Similarly, this is another example. OpenAI, one of the product of Google, defeated the world Dota 2 champions in last year. This is just to show, you see, the development in AI and research in AI has come to that level where it is also possible to build solutions which can have almost similar human intelligence or intelligence almost similar to humans. This shows the capability, the possibility. But the applications of AI and machine learning in different domains are broader, right? So it is used in manufacturing for predictive maintenance. A number of manufacturing organizations, including the organizations and companies in Indonesia, have also started using predictive maintenance, wherein they can now predict using IoT sensor data when a particular machine will fail. What should be the warranty for a particular product when it comes to insurance? Telematics, where collecting data from different sources, moving objects, supply chain management, smart supply chain management, demand forecasting for manufacturing plant. Number of healthcare organizations in Indonesia, Jakarta, have started doing a lot of research on implementation of AI for predicting the tuberculosis, predicting the drug addicts, those all. In retail, upsell, cross-sell predictions, market segmentation, inventory planning, financial services like risk analysis, customer segmentation, and credit worthiness evaluation. These are different other applications of machine learning, data science, deep learning in different other domains. So it is used in retail, healthcare, travel and hospitality, energy feedstock, and different utilities. These are all different applications which are popular applications across the world. And almost every industry in different domain have started adapting relevant solutions. So what to learn in machine learning? Well, how to become expert in machine learning? Well, so there is somewhat mathematics and programming, which you can learn in some of the smart courses provided by Google. So we have, in order to learn machine learning, these are different, the segments that one should be aware of. Talking broader about it, you can start with learning Python, programming, right? Because machine learning algorithms require programming. So you can learn programming. Python is one of the top programming language used for machine learning applications. Other than that, you can, so first thing you can try out is programming. Then the statistics for machine learning, mathematics behind machine learning, the packages, advanced packages like TensorFlow, Keras, the piano, optimization techniques, a lot of practice on real-world challenges and smart projects. At Budap also we take some capstone real projects as well, and then understanding of how to handle big data. Right, these are a couple of segments one needs to be good at, right, in order to excel in machine learning. All of them are not immediately required, but yes, you can start up with programming, and that too, Python. Python is the best, one of the widely used programming language. And after that, R is also one of them. So, well, now we're going to go ahead and talk about okay, AI is good, machine learning is good, but why should I care about it? Okay, so what it has to do with Indonesia and how it is going in Indonesia, and what are the some real world challenges that we or you can say problems that are there in different countries and also in Indonesia as well. Like every country has industries specific to manufacturing, retail, healthcare, right? The particularly education, and the development comes into that, right? The modifications, the improvisation of software, ERP solutions, the operations, and that's what is also started happening in Indonesia as well very quickly. So this is one of the report, right, about the spread and the adaptability of artificial intelligence and machine learning market in Indonesia. So one of the study, this is done, for which the link is available probably. This is from appear.com. You can, which is a research firm. You can check out report, the Forrester report on AI in Asia Pacific. So Indonesian organizations, the startups, big companies have started investing heavily in AI-related products, AI-related solutions, hiring heavily, and there's been a lot of good demand by them in this particular field. So this is one of the research by the company called Appear.com, the website called Appear.com. And according to this, they say that almost, or whatever the research they have done, 65% of the respondents in Indonesia claim that, well, they had implemented AI in their company, and they are also developing a lot of AI solutions. This is one of the report or analysis of their research. So this shows that you can see in Asia Pacific segment, Indonesia is one of the leading country in terms of the collection of startups and the big organizations which it has, and how keen they are, and how positive they are, and how active they are in terms of implementing AI solutions. So more than 65% of the respondents have implemented, or they're expanding, or they're upgrading the existing solution with AI. 22% of them are going to implement that in next 12 months. So, and only 13% of them have no plans as of now, but will probably over a period of time, they'll have to also shift it to the similar segment. The stages of implementation, right? So this is what the research shows, right? So this is what the idea of the possibility of AI in Indonesia and in the companies growing up. So this shows the sort of time that we are into is one of the most relevant and the peak time to get into something which is going to be the disrupting market in coming years. Now we can talk about sort of the idea of how do we leverage the power of artificial intelligence and machine learning in Indonesia. So the most popular applications of AI and ML in Indonesia have been into the couple of fields. One of them is improving the agriculture with smart predictions about the crops to be grown, the season, and the water requirement, and all of them. Anticipating the natural disaster using sensor data and the patterns on the past data collected. Healthcare is one of the sector where majority of the Asia Pacific organizations have been growing very quickly, and Indonesia have been one of them. Recently, I went into some of the health conferences. One of them was Arab Health Conference. So like there have been a lot of Indonesian organizations that have been going with very quick growth rate in terms of implementing AI solutions in uh, Indonesia and the healthcare market, and are one of the leading one as well. And then the educational areas, the manufacturing, these are also a couple of fields where Indonesia has started leading up in terms of smart solutions using artificial intelligence. Some of the AI and ML startups we have here in Indonesia that we can talk about, right? So one of them is Snapcart. So Snapcart is a portal where they allow other companies to collect a lot of data like purchase data and the customer user data, and help them to get a lot of insights that what makes customer buy the product. So they have served to a lot of clients like Johnson & Johnson, Unilever, P&G, Nestle. So they provide these customers the insights about what makes the customer buy the product, in what season they buy the product, in which cities, what economical condition, educational level makes the customers buy the product. So those all kind of insights and intelligent patterns these companies, this particular company helps them to find out. Similarly, we have, this is another company, right, from Indonesia, and that is Kata.ai. And this is from Jakarta and has got recently a big investment as well as venture funding. And they are into conversational AI, that is the field of natural language processing, where they provide chatbot solutions to the banking, healthcare, and retail businesses. Then the other company, right? So this particular organization, Basa, is also into the conversational AI or NLP modules. So they provide NLP modules for text classification, conversational support in sales to a number of organizations. DataNest. DataNest is another leading Indonesian startup, and they are into the field of AI machine learning. They partner with, they have partnered recently with a couple of fintech industry, so as to help them in banking, finance, stock forecasting, currency management, currency accreditation, then risk analysis in finance, lending, the analysis of asset, right? So these in these all cases, DataNest have been working into. iGrow is one of the company which have been helping the Indonesian government and farmers to improve their format of, or you can say, way of working in agriculture and use technology to improve the productivity in agriculture domain. Eureka is another platform for AI, Indonesian platform, and they help for smart predictions to the very popular companies from the domain of banking, insurance, transportation, right, and consumer goods, and also some of the manufacturing as well. So these are all like this set of the growth that we have seen over of a period of time in the field of AI, and this is what the set of growth we have seen in specifically in Indonesia about the positive move towards adapting AI and utilizing the power of AI to improve the current efficiency, reduce losses in the business, increase the customer market base, and provide better solution and experience for the customers as well. So this is where the move started up, and that shows the sort of opportunity and possibility of implementation and growth we have in the field of artificial intelligence machine learning in Indonesia. Well, so that's all about it. And next part that we can talk about is, let's see with an example that, well, how machine learning could be helpful in customer churn of a telecom company. So you can consider this scenario as the idea of the data collected from the citizens of Indonesia by a telecom company, and utilizing that data to predict whether a customer will churn or not churn. So let's understand first what's the meaning of churn actually. So customer churn means when a customer is about to leave an organization, when a customer is about to join another particular company. So we also call it customer attrition, where the company is going to lose a customer. So it is very important for the company to identify that because of their competitors or because of the particular services being offered, or because of limitation of their services, if there are customers who are not satisfied and are going to drop them out. So to identify those customers, the churn prediction is done. And then once those customers are identified, the telecom companies usually provide them some attractive offers so as to retain those set of customers. So this is the use case, right? Let's understand the data set, and then we'll work out on this example. Okay, so here we go. All right, so this is the data set that we have. We have data of around 7,000 customers of a telecom company, 7,043 customers, as we can see that here. Well, for every customer, we have some customer ID assigned by the organization, by the company to that particular customer. We have gender of the customer, which is this customer is female, this customer is male, this customer is male, and this is female. Then this attribute shows whether that customer is a senior citizen or not. So 0 shows no, customer is senior citizen. 1 shows yes, customer is senior citizen. This attribute shows whether the customer has partner or the customer is single, right? It's like married, unmarried. So no shows no, customer is not having a partner. Yes, customer is having a partner. Dependents, are they dependents or not? So yes shows yes, customers has dependents, could be kids, could be siblings, could be parents, or could be the partner. Tenure, how many years or how many months it's been the customer is still associated with the company. So this customer has joined the telecom company 1 month back, this customer has joined 4 months back, this customer has joined 2 months back, this customer has joined 45 months back. That means more than 3.5 years. 22 months back, 10 months back, 8 months back. So tenure shows how many months it's been the customer has joined the company. Well, the customer uses phone service or no. So no shows yes. I mean, the customer is not using that phone service, and yes shows yes, customer is using the phone service. Is it customer using multiple lines? So you see, this kind of data is being collected from all the customers, whether the customer using multiple lines, yes or no. Is it customer using internet service? What kind of that? So DSL or fiber optic or not at all, or fiber optic or DSL. Is it customer using some antivirus for online security? Yes or no? Or customer is not at all having internet secure service itself. Is it customer using some online backup? Is it the customer's device protected? Is it customer uses tech support? Customer is using streaming TV? Yes or no? Is it customers also streaming movies as well? Yes or no? So what kind of contract the customer is having with the telecom company? So it shows, well, this customer is having month-to-month contract, but this customer is having 1 year contract, month-to-month, 1 year, like that. Is it customer is accepting paperless bill? Yes or no? So yes shows yes, customer is accepting paperless bill. No shows no. Now you see, we never know that whether this is going to be impacting or relevant to the customer will be leaving the company or not. We'll have to do analysis of that, and that's the very important part of implementing machine learning and data analysis. Payment method. What is the payment method? So this customer pays via electronic check, this customer pays via bank check, or email check, bank transfer, credit card, automated payment, like that. So these are all different payment modes. What is the monthly charges? So these are all monthly charges in dollars, and total charges in dollars. And then, did the customer churn or not? So no shows no, customer did not churn. That means customer did not drop the company. Customer did not left the company. Yes shows yes, customer has left the company, and that's where this customer might be having certain pattern, certain problem. So the objective here is that we can help out this telecom company by first analyzing this pattern and sort of identifying the reasons why the customers have been leaving, and then developing a machine learning solution which can be used by them to predict that out of the existing customers, which of the customers are more likely to leave. if they know this in prior, it will be very helpful for them to provide some offers to the leaving customers and retain them and sustain their business. So every business in retail has kind of this problem, right? So the main objective is to solve the problem, help the organization develop a machine learning solution, and also identify the patterns. Let's get started. So we're gonna use Python for doing this, right? Okay. Syntaxes might be, if you're not in Python, programming with Python, syntaxes might be new for you, but you'll understand the logic. That's gonna be very interesting. Okay. So this is the data set that we have. I'm gonna copy the path of this particular file, right, which is gonna be, just a moment. So here we have the code. All right. So the project overview is we are going to work on predicting customer churn using machine learning. Customer churn is where the customer is going to drop the company. We want to identify that in prior. If a telecom company can identify that in prior, by providing offers, by providing relevant offers, they can retain that customer. So let's do this. So first, dataset overview. We already discussed the dataset, right? So we have these attributes, the customer's data. They have phone or they have multiple lines or not. Do they need tech support, right? They have internet, they have online security, they have online backup, device protection, tech support. And we have data like how long they have been the customer, contract, the payment method, whether they use paperless billing, monthly charges or not, gender, age, if they have partners or dependents or not. So first thing that we'll do is we'll load the important packages. These are a couple of popular packages in Python which are used in machine learning. NumPy for numerical computation, Pandas for data import export, Matplotlib for visualization, Seaborn for visualization. In number of put up courses, we work on these packages from very scratch, and we work on this and learn this use of these packages as well. Right. So we have a question by Faldi. Faldi, I'm going to take your question in sometime, right? So once we finish up this part. So yep, I'm going to take your question. I got a question is that, well, in terms of churn prediction, you want to know that, well, how do we predict that when the customer is going to drop actually, right? So we're going to take that up once we finish this. In a nutshell, I'll tell you, there is also one more parameter that we usually use, which is like the gap between the duration for the customer, for that the customer stayed, right? So let's say customer joined in June 2018 and dropped in December 2018, right? So that's where that's the 6 months period that customer has dropped out, right? So the customer has been associated. So based on the pattern and the time period, we can do this analysis of in what time customer is going to drop, right? So we always take window size as well sometimes, right? So 6 months window size or 3 months window size, and if there are more chances of dropping the customer in the 3-month window or more than that, and based on that taking action. So we'll discuss in detail about that once we end up with this particular exercise, right? All right, so here we go. Let's go ahead further. So we loaded the package. And now we're going to load the data set here. So I'm going to provide the address to my data set over here. And here we go. Okay, so it shows me an error. So I'm going to put here R for cross string. So we have loaded the data. Let's see the data. So this is the data that we have loaded up. which shows the properties of the customer ID, gender, whether customer is senior citizen or not, customer has partner or not, dependence, tenure, phone service, multiple lines, internet service, online security, backup, and all the properties. To have more insights about the dataset, we can check it out, df.info, which shows the data type of every observation, the whole size of the image, size of the dataset. So we have total 7043 entries, and the index of that starts from the 7590 to 3186 exactly, from this value to this value. The columns include 7043 and so on and so forth. 7043 not null value, that means non-missing values. And so many of the observations are object type, which should be more of, you can say, numerical. For example, the monthly charges is plot 64, but the total charges in object, that needs to be converted to numerical because charge is like a number. Then the customer churn or not churn. The total size is more than 1.1 MB. So there's one attribute which is float 64, 2 attributes which are int64, and 17 attributes which are object. So first thing that we see here is that the total charges is an object variable, right? Because the total charges should be a numerical value. So we'll convert that into float. So here we go. So in this section, we have converted that the total charges from an object format to a float format, or you can say numerical format. And now we check the info, right? So now we can see that the total charges is converted into float 64 format or numerical format. So once that is done, now we can go ahead and perform the exploration of data, right? So there we can do the analysis that, well, what makes a customer leave the company? What makes a customer drop the company? Let's do that. Now this is going to be interesting. We're going to be able to identify interesting patterns over here. So first, let's understand this one, the partner value counts. That how many people are there who have partners and who don't have partners, right? So this shows that you see the count of people who have and who do not have partner is almost closer. There's way less changes in ratio. So there are almost 50% people who don't have partner, slightly higher than that, and slightly lesser than that who have partner. Similarly, let's look at senior citizens. So there are very less people who are actual senior citizens, and majority of the customers of the company are not senior citizens. As you can see that more than 80% of the customers are not senior citizens, and slightly less than 20% are senior citizens. Similarly, gender. As we can see that the count of males and females is almost equal in the company, right? So they have almost equal number of male and female customers. Males are slightly higher than the count of female, not much. Then tenure, the time for which the customer is associated. So this shows majority of the customers joined the company last 1 month back. Then there are highest number of customers who have joined from last 72 months, right? That means those are kind of very loyal and long-time customers which have not left the company so far, right? And there are number of customers who have just joined last month back, 1 month back. Then 2 month old customer, then 3 and 4, then 71, then 5 and 7, so on and so forth. So tenure shows a lot of pattern, and this could be analyzed to check that which of the set of customers are less likely to leave. Then we're going to talk about whether the customer is using phone service or not, and the sort of you can say pattern into that. So they are more than as we can see that closer to 90% of customers who are using phone service, and less than 10% of customers who are not using phone service, right? And Then we go ahead further. This is where we're going to check out the multiple lines, right? So there are closer to 50% of customers who do not have multiple lines, and more than 40 have. And almost closer to 10% of customers are not at all using phone service, the internet service analysis. All right, so this one is going to show us that whether they use internet service or not, or what is the pattern. This shows that more than 40% of customers are using fiber optic, closer to 35% of customers are using DSL, and closer to 25% of customers are not at all using internet service. Then we're going to see whether they are having contract val or not, right? So what kind of contract they have, like year to year or month to month or 2 year. The majority of the customers, as you can see, that more than 50% of customers do have month to month contract, and closer to 25, 2 years contract, closer to 20 are having 1 year contract. And finally, we can check out the payment method. How is the data in the payment method spread out? So this shows that, well, a majority of them prefer electronic check, 33% of them almost, 23% of them prefer mail check, and then 20% of them almost prefer the bank transfer, 20% of them prefer the credit card. So these are all the data that we have visualized in one variable. Now we want to see that how these variables are impacting the possibility of customer leaving the company or not. Right. So that's what we are going to analyze now. So how does the phone service impact? How does the internet service impact? How does the payment method impact whether the customer will leave or not leave? Right, from the data. So here we go. So now first thing that we're going to see is that, well, how many customers total dropped out? So out of 7,043 customers, 70% of the customers did not drop, and closer to 25% of the customers dropped out. Now let's see the impact. So here we're going to see the impact of gender, right? How gender impacted customers dropping or not dropping. So total there were 3,488 customers female and 3,555 customers male. Out of them, the dropped out female are 939, dropped out male are 930. If you look at ratio also, right, so this is the sort of pattern in that male, female and all. If you look at ratio also, so you can see that almost 50% of females dropped out, and almost 50%, closer to 50% of males. So that shows, you see, the dropping rate in female and male is almost equal, right? The dropping rate in female and male is almost equal. That shows that gender doesn't impact. Gender of the customer doesn't play an important role in predicting whether the customer will leave or not leave. Now, this is not machine learning. This is where we are doing only the analysis part, interpreting that which features are important to identify that. Similarly, let's go ahead and do it for contract. So whether they have month-to-month contract, 1 year, 2 year, how does that impact? If you look at the ratio shows much better understanding. 88% of the people who left, right, were having month-to-month contract. Only 8% of people who are having 1 year contract left, and 2% of people, 2% of the customer who are having the 2 year contract left. That means those customers who have 2 year and 1 year contract are very less likely to leave. That means this particular feature, the kind of you can say contract type is an important one and is impacting one, right? Next one, we'll talk about the internet service. How does the internet service impact it? Let's look at the ratio to have the better idea. So DSL, 24% of people who are using DSL internet dropped out. 70% who are using fiber optic dropped out, and only 6% dropped out who are not using internet. That means this also impacting it. This is also an important feature and is impacting the behavior of customers dropping or not dropping. Next one we're going to see is like the tenure. Right. So we missed out the tenure. Right, here we go. Right, so with respect to tenure, as you can see that the median, less than median, higher than median tenure, right? So there are 5,000 who are not dropping with the median value, and 1,800 who are dropping out, right? Similarly, that for the partners, right? So and dependents. Okay, so for that we have this particular pattern. Then we can look at ratio for having the partners that had dependent and the partners, known partners that has dependent. So 82%, 70%, that is higher change, right? So as we can see that the partners that has much larger percent of dependents than known partners, uh, uh, this shows that, well, the partner shows that those people who had partners are the married people. And now let's see that how did this impacts out. So if you look at the impact, so this is where, I'm sorry, I missed it. Here we go. So if you look at the impact when it comes to partner or non-partner, so we find that, well, there's almost similar impact out of all versus people having partner and not partner. Almost closer. There's people with no partner are staying slightly larger, lengthier. Right. And then this is impact of tenure. As you've seen, tenure is already impacting 72-month and 70-month kind of people are pretty much not dropping out, right? And then partner versus churn again, right? So, and here we have senior citizen versus churn. So these are all analysis that we're doing. As we can see that senior citizen also is impacting pattern, right? So after that, we're going to do here the box plot analysis. This is all about the normal analysis that we do on the data to understand that, well, what is impacting our target attribute. As you can see that in monthly charges, there are no outliers, there are no extreme cases. In total charges, so this is where we are analyzing that, is it there are people who are actually having very extreme charges, low or high charges? So no, there are no outliers into this as well. Now we can see the statistical description, right? Finally, we can see the correlation matrix. Correlation matrix shows the relationship between total charges, monthly charges, tenure, and senior citizen. So as you can see that total charges is heavily correlated with tenure, which is logical. Those people who are longer will have larger total charges. And it is also good correlated with monthly charges as well. Right? And it is not at all correlated with kind of much correlated with senior citizens. So it doesn't matter. The patterns like those people who are senior citizens are going to spend more. That pattern doesn't exist. Well, so that's sort of analysis we have done. Okay, now we can check out the missing values, whether there are some values missing or not. So here we see that, well, total charges have some missing values. That's a big challenge. Okay, so we can fill that up. So here we are tried out filling the missing values. Now we are going to just check that what about the monthly charges and total charges, right? So those people who churn. So the median monthly charges of those people who dropped from the bank is $79. The median total charges $703. Then the median tenure is 10 months. So these are all other patterns that we analyzed, right? Similarly, that we can do other analysis over here. And finally, we can go ahead and prepare data for machine learning. So here we're going to go ahead and prepare data for machine learning. So we're going to drop some columns which are not important, like partner, dependents, phone service, multiple lines. We identified that these features are not much impacting our target. Our target is whether the customer leaving or not leaving. So we're going to go ahead and drop this. So we have dropped these features. After that, we're going to encode the categorical features. So we have dropped here and encoded them. And finally, this is our final data set that we have, in which all our observations are either numerical or in float values. So now we're going to go ahead and implement machine learning over here. So separate the target, we separate the features, X is features and Y is target. We're going to split our data into train and test, right? So this is also one of the answer to the question, how do we evaluate it, right? So we split our data into train and test. Majority of the 80% section will be using to train the model, and 70% section will use to train the model, 30% to test the performance. Okay. So here we've done that. Now we'll import one of the very simple and popular machine learning algorithm, that is logistic regression. So this is the algorithm which can be used for developing or solving this problem, developing classification model. Then with that, created an object and train the model. This is where we are done with training the machine learning algorithm. We can check the accuracy. So this shows the confusion matrix. The accuracy of the model is somewhere around 80%. Recall is 51% and accuracy is 80%. Right. So this is where we have done the prediction and found out that we have 80% of accuracy in predicting those customers who are going to leave or not leave, and 50% of recall in identifying all those customers who are going to leave. Well, so that's the idea so far about developing a telecom churn prediction model. We could have done a lot of other feature engineering in this and tuning of model, changing the algorithm to improve the performance further. So that's all from my side, everyone, and the analysis of telecom churn prediction. Now we are open to questions. We'll be taking questions over here, right? And you can put your questions in the question box. So I'll be able to answer all your technical questions, right? For more related to that, you can reach out to Amir or Vindy. Okay. So,
Hello, Mr. Anju.
yes, Vindy.
Yes, so we got so many questions here. May I read for you?
Yeah, let me take a couple of technical questions, 3 to 4, and then you can take it over.
Sure,
Okay.
sure. Go ahead, yeah.
Okay, so there's a question, how can we build algorithm using NumPy only, not using tool that had already provided such scikit-learn? Well, we can code the mathematics behind algorithm, right? So every algorithm has mathematics. So in the boot up courses, we also take the coding of algorithm from scratch, and then also using the pre-coded mathematical models as well. So we go in both the way. So we use packages like Theano, TensorFlow, NumPy, and using that developing neural networks, or developing neural networks using Theano or using NumPy, using TensorFlow, where we hard code the models. So just we need to understand the mathematics, and we can hard code the models as well. All right. I have the answer question. Yes, that's what. So you see, this is the difference between learning from internet and learning from a mentor, right? So the question is like, in scikit-learn, it looks like magic. What happened that we don't know? And that's where when you learn from a mentor, where you understand the mathematics, you check the feasibility of mathematics, you verify the mathematics, and then that helps you understand that, well, what's happening inside. With ready-made things, you may be able to just copy and paste code from internet, and that may help you out to just get the model, but you will not be able to optimize the performance of the model until unless we know the backend, how actually it works out internally. And that's where majority of the courses at Bootup and programs at Bootup focus on. There's a question for real problem. Where can we get the test data? Is the problem comes from the test data? No. For real problem, we first collect data, and from the training data itself, we divide that data into 2 sections, and one of these small section we keep it for testing. There's a question, so we can take only 2 questions more, right? So if you have any technical questions, please put that here. I won't be able to answer any non-tech questions, but yes, you can put here questions. All right, so a machine learning model use only clean data. How can we, how do we clean the data, right? So, well, for cleaning data, we have to handle missing values, we have to handle duplicate values, we have to handle outliers, and for that, there are options to, let's say, replace the missing values by mean, mode, median, duplicate, drop them, right? What should we do with bad data? Well, bad, that's what we outliers, we remove them. So in a number of cases, we Rather than developing 90% accurate model on 100% of data, we go for 95% accurate model on 90% of data. What should we do with missing data? We should replace that by mean or median. How can I make sure that synthetic data is accurate enough for replacement of missing data? Well, so there are patterns to do that as well. Right? For example, let's say customers who are dropping their mean used to replace the missing data of customers who are dropping. So there are also machine learning ways of handling missing data as well. So there are a number of techniques to handle that. Is there any value, EACT value threshold on deciding remote attributes? Well, yeah, they are actually. It depends on the quality of data that you have. It depends on the impact that you have. For example, in correlation, you can take a threshold of it should be greater than 0.1 and less than minus 0.1. Then it is good correlation. That kind of threshold you can take. Similarly, in different business problems, we have different tolerance level to be assessed. How much a best row of data for train and test can you tell percent? 80-20 and 70-30 are the best one. 80-20 is more practiced one. How if the data set is not in CSV? There are different ways to load from different other sources. You can use Beautiful Soup, you can use Pandas for doing that. Last question we're going to take, how do we know the quality of data? So by doing analysis. Sometimes that data has been collected, not all true as in fact. Still there are data that is not used. So how do you know that? Well, so that's what we do analysis on that. The analysis and exploratory visualization, statistical analysis helps us out to do that. So that's all from my side, everyone. I hope we are all good. So Winnie, now you can take it over. Thank you.
Hi, Mr. Anshu. Thank you. Thanks for sharing with us. It was very insightful.
Thank you.
So, yeah, thank you, Mr. Anshu. So, guys, it's a wrap. Sayangnya kita harus mengakhiri webinarnya nih. Nah, buat yang tadi merasa ada miss-miss sedikit karena nggak bisa dengar audio atau screen-nya, nggak usah khawatir karena kamu bisa akses kembali record webinarnya di channel YouTube kita. Lalu untuk yang share pertanyaan, ini kita receive banyak banget pertanyaan, semuanya technical. Nanti akan kita share, kita langsung reply ke email kalian dengan jawaban dari Mr. Anshu ya. Nah, aku juga mau share untuk kamu yang belum tahu, Burap Academy atau Burap AI itu apa sih? Jadi Burap AI ini adalah sekolah coding dari Silicon Valley yang memiliki 4 pilihan program, yaitu Data Science, Artificial Intelligence, Machine Learning, dan Coding. Burap sendiri adalah akselerator startup AI terkemuka, penyedia coworking space ternama, serta partner perusahaan berstandar global yang berpusat di Silicon Valley, Amerika Serikat, sejak tahun 2015. Di Indonesia, Burap juga menyediakan akses besar ke dunia kerja, khususnya dengan para partner perusahaan dari grup Burap di Amerika dan Indonesia, gitu, seperti Tokopedia dan unicorn company lainnya. Nah, jadi guys, jika kalian tertarik untuk kelas yang lebih advance dan complete, bisa banget sign up di website kita. Nanti tim Burap bisa menghubungi kamu. Untuk kelasnya sendiri terjangkau banget. Kita ada kelas 6 jam dimulai dari Rp299.000. Untuk kelas flex dan imersif sendiri mulai dari Rp6.990.000 hingga 39 juta, tapi nggak usah khawatir guys, karena bisa kamu cicil. Jadi kita ada beberapa financing plan partner kita kayak coinworks.com dan nanti kita in the future payment optionnya bakal mudah banget buat kalian. Nah, kapan lagi kan kalian bisa belajar sama experts dari Silicon Valley, dari pusat teknologi langsung dengan harga terjangkau dan waktu yang fleksibel, setuju nggak? Oke, aku juga mau info bahwa weekend ini 8 sampai 9 Februari 2019 besok pukul 10 pagi sampai dengan setengah 2 siang kita akan memulai kelas live webinar kelas 6 jam untuk program coding kelas foundation yang akan dilakukan secara online. Jadi hari Sabtu 3 jam, hari Minggu 3 jam, mulai jam 10 sampai jam setengah 2 siang. Nanti ada break-nya. Nanti kalian juga setelah akses itu selesai bisa tetap dapat akses lagi. Jadi kalian tetap bisa akses learning center kita. Cuma 299.000 aja guys. Gila murah banget kan. Nah, langsung aja DM, WhatsApp atau email kita, tanya-tanya, discuss boleh banget. Tim Burap siap banget ngebantu dan nggak perlu khawatir karena untuk semua programnya ada sertifikat yang bagus banget buat portfolio kamu nantinya, terutama di industri ini. Kalau misalnya bingung mau coba yang sebulan atau 6 bulan, coba aja dulu yang 6 jam guys. Nanti kita lebih belajar dalam, nanti kan kita bisa diskusi, kita juga bisa, kamu juga bisa discuss, konsultasi sama kita, oke? Oke deh guys, on behalf of Mr. Anshul as well as the team at Bura, thank you for joining us and taking time to attend our webinar. My name is Windy. Have a good evening guys.